Hi there, Mr. Holcomb here with another lesson in pre-algebra. This is session 3 of the student companion book. It's a supplement to the text, and it's all about exponents. So this is applying properties for powers with the same exponent. Read and try to solve the problem below. So I'm just going to scroll up to about here, and it says Ronnie and her mother make rangoli for their family's Diwali celebration. They make one rangoli design that is a square with the side lengths of 15 inches. So right there, I'm going to label my diagram. This side is 15 inches, and this side is 15 inches. Okay. They make a larger square design by tripling its side lengths. How many times as large is the area of the new design than the area of the original? Okay, so there's some stuff going on here. 15-inch side lengths. We're going to triple those side lengths, and we need to know how many times larger is the area of the new design. Okay, so the first thing I want to do is find the area of the original design. An area of a square is side times side or length times width. I'll just use length times width here, but it's also side times side or side squared. So the area will be 15 times 15, or the area will be 15 squared, if you will, okay? And that comes out to be 225 inches squared. So that's the area of the original rangoli. But now we're going to enlarge it by side lengths of 3. So I'm just going to do in class what we did. And what happened in class was students were like, well, just multiply the area by 3. So when I do that, I get 15. 3 times 2 is 6, plus 1 is 7. And 3 times 2 is 6, which is 675, okay, inches squared. So then I was asking them, well, let's just double check, make sure we're right by doing the formula again. But now we're going to triple each side. In other words, multiply each side by 3, which is now going to make each side 45 inches, right? 15 times 3. So this is now going to become 45 times 45, or the area is going to be 45 squared. So that's going to come out to be, I'll just do this over here. 5 times 5 is 25, carry the 2. 5 times 4 is 20, plus 2 is 22. Bring down a 0. 5 times 4 is 20. Bring the 2. 4 times 4 is 16, plus 2 is 18. Add them up, I get 5202 inches squared. So this is the actual correct answer. 2,025 square inches. So then I asked the students, well, what could we do with this to get that? And I was hoping to hear that some of them would say, well, to find out what you're multiplying by, divide the bigger number by the smaller and we can find what it was being multiplied by. But they didn't come up with that. Instead, they said, well, multiply it by 3 again. So I did. And I get 7 times 3 is 21, plus 1 is 22, carry the 2. 6 times 3 is 18, plus 2 is 20. And lo and behold, we got the same answer when doing that. So I said, why did we do that? And they responded, or a couple of the students anyway, responded that, well, when we multiplied this by 3, we were only taking into consideration one side. And that would make this 45, but this would still be 15. So now it's a rectangle. So that was a really good observation. So they said we have to multiply it again by 3 to get the other side multiplied up by 3, if you will, or tripled. And that is exactly what happened. So then we had the discussion of, well, what is 3 times 3? Well, it's 3 squared, and that becomes 9. So the answer to this problem is 9 times. Okay, so it said, how many times as large is the new design? So that's the way we went around about doing it. This was just a discussion a trial and error type situation, but on the next page, we're going to start doing what it is actually wanting us to do. So in the model, it says you can use a fraction to compare the areas. The original side length in inches was 15. The new side length in inches was 3 times that 15. So all we have to do is find the area of the new design, which is 3 times 15 by 3 times 15, and then divide that by the area of the original design, which was 15 times 15. So all that was doing was coming back to here with me saying, well, hopefully some of them would say, take this 2025 and divide it by this 675, but in this case, it'd be 225. And that would be the fraction we would use to determine that it is 9. Okay, so that's what we're leading up to here. So then what they did was this 3 times 15 twice, they rearranged the 3's and the 15's and put them in their own parentheses. We can do that because multiplication is commutative. So that still means the same thing. And then when we do that, we can separate the 3's out over here. Sorry about that. I thought I still had mine. So here's the 3's over here, and the 15 over 15's are going to cancel because any 15 divided by 15 is 1. Okay, and when we multiply by 1, nothing changes. So our actual answer is going to become 3 times 3, which is 9. Okay, and then the new model, it says you can use a power expression of the area of the new design. The area of the original design was 15 times 15. Find the area of the new design in terms of the area of the original. The area of the new design was 3 times 15 squared. So they're saying that if you have 3 times 15 squared, that means 3 times 15 times that again, because that's what squaring means. Rearranging the 3's and the 15's will get us here. Well, this would end up being 3 squared times 15 squared. Okay? So this became that. And that is what we're leading up to. It's the distribution of exponents. It's the power rule. And I'll explain that more on this page here. So now here's the connect it. It said, use the problem from the previous page to help you understand powers of products and powers of quotients. How many times as large is the area of the new design than the area of the original design? Okay, well, I'm not going to go back. It was 9 times as large. We already answered that. The second model, it shows that 3 times 15 squared is 3 times 3 times 15 times 15. Rewrite the right side. So let me highlight that. They want us to rewrite this as a product of 2 powers. Okay, well, 3 times 3 is 3 squared, and 15 times 15 is 15 squared. So this is a product of 2 powers. Okay. B says, how can you write an expression equivalent to A times B to the n as a product of 2 powers? Okay. Okay, well, look at, we have this. Let me erase this. We have this, and it became this. So that is an equation as a product of 2 powers. So we're taking the 3 times 15 in parentheses squared and distributing the power to both values. So this problem is giving us the general rule. So A times B to the power of n, where A and B are real numbers, and n is a positive or a whole number, positive integer, we can distribute the n. So A to the power of n times B to the power of n. Okay, it's true for any base and any exponent that's positive. Or negative, actually, but there's other rules for that. So B says, or C says, the expression 3 times 15 squared is a power of a product. How can you write the expression 18 times 35 cubed as the power of a product? Okay, so students were struggling with this because it's very wordy. But 3 times 15 squared, they're telling us, is a power of a product. And then it's telling us to write this as one of these setups. Okay, that's all it's saying. So you want your parentheses and you want your multiplication point, and then you just put your two bases in here. So here's 18 and here's 35. And we can do this when the powers are the same and they're both 3. And that 3 would go outside here. And that's it. Okay, so then number 3 says the side length of the original design in feet is 1.25 or 5/4. The area of this design in square feet can be written as a power of a quotient. Okay, let me highlight that. This is a new term. Power of a quotient. And here it is. It's a fraction raised to a power. So this says 5/4 squared is equal to 5 times 5. Or I'm sorry, 5/4 times 5/4, because when you square something, it's that thing times itself. And since that is, we have this, then that equals 5 times 5/4 times 4, which does simplify to 25/16. It says to rewrite 5 times 5/4 times 4 as a quotient of two powers. So that's going to be 5. And so there's a power here. 5 times itself is 5 squared, and 4 times itself is 4 squared. So this is a quotient of two powers, just like this was. Okay, see how it says it? Now B says, write this expression 5/4 to the 6th power as a quotient of two powers. Well, all they're asking us to do is take this 6 and distribute it to the numerator and the denominator. So this is going to be 5 to the 6th over 4 to the 6th. That's it. That's all they're asking us to do. But then it says, show that the expressions are equivalent by writing the powers as a repeated multiplication. So 5 to the 6th power is 5 times 5 times 5 times 5 times 5 times 5. 1, 2, 3, 4, 5, 6 over 4 times 4 times 4 times 4 times 4 times 4. Okay, so 5/4, 6 times. Now you see that we have 6 fractions of 5/4. So we just showed by repeated multiplication that they're equivalent. Now the apply it. Use what you learned to solve these problems. How can you write 8 to the 4th times 7 to the 4th as a single power, meaning one exponent? Well, all you need to do is take the 8, the bases, 8 times 7, and put them to the power of 4 because they are the same. Number 6, which expressions are equal to this? Select all that apply. So I'm going to write this, I'll do it over here. So it's 12 to the 1 times 17 to the 4, all to the 5th power, divided by 17 to the 10th power. So when we're doing this, we want to distribute our 5 throughout the parentheses, but the parentheses do not include the denominator, so this is all we're going to do. I'm going to show all my steps, and the power rule is multiply. So this is going to be 12 to the 1 times 5, 17 to the 4 times 5, all divided by 17 to the 10th. So 12 to the 1 times 5 is 12 to the 5. And 17 to the 4 times 5 is 17 to the 20th, all over 17 to the 10th. So now I'm going to check, and this 12 to the 5 times 17, is it anywhere? 12 times 12 to the 5th times 17 to the 20th over 17 to the 10th. Okay. Okay. So now what I can do is focus on, I'm going to simplify this further. I have a 17 to the 20th and a 17 to the 10th. So this can equal 12 to the 5. And the rule for division is subtract. So that's going to be times 17 to the 20 minus 10, or 17 to the 10. So 12 to the 5 times 17 to the 10 is an equivalent expression to the original. So with that being said, we have a 12 to the 5 here and here, but this 17 to the 10 does not match 2. So now I know A is not a solution. Okay. And if I go back to here, 12 to the 5 is here, 17 to the 10 is here, but they got 17 to the 9. So instead of multiplying, they made a mistake and added here. Okay, that is not the right rule, so E is eliminated. Okay, now I'm going to do B over here. Notice the parentheses are in the numerator and denominator. The whole fraction's inside, and it's 12 times 17 to the 4th power, all to the 5th power, over 17 squared. Well, if I distribute this 5 here, here, and here now because of the parentheses, then I will get 12 to the 5th times 17 to the 4 times 5, which is 20, over 17 to the 2 times 5, which is 10. Okay. And then this reduces to 12 to the 5. And actually, it's the same as right here. These two are the same. So now I know B is also going to give us a simplified value that is equivalent to C. All right, D. All we need to do here is distribute. So I have 12 times 17 squared to the 5th. So if I take this 5, let me use a different color. Whoops, let me put that back. If I use a different color, this 5 right here is going to go to that 12 exponent, and it's going to go to the 2. So 12, that's a 1. 1 times 5 is 5. And 17 to the 2 times 5 is 10. So again, we come up with 12 to the 5, 17 to the 10. So D is also an answer. Okay, but F is not, because 12 to the 5 is here, and there is no 5th power here, yet 17 to the 20 and 17 to the 10 match. So F has been ruled out as well. So the answer to this is B, C, and D, but not A, E, or F. Okay, next problem. This is a physics problem. And what this is saying is, let me switch to a highlighter. When a rubber ball is dropped on a particular surface, it bounces back up 8/10 of its drop height. The ball's height after bounce x is 8/10 to the power of x times its drop height. What fraction of its drop height does the ball bounce up after its 4th bounce? Show your work. Okay, so I did this in more detail in class, but I'm just going to cut to the chase here. And all they're asking us to do is take 8 over 10, okay, which is 8/10 or 80%. So if this was dropped from 5 feet, 80% of 5 feet is 8 times 5, which is 0.8 times 5, which is 4. So after the first bounce, it would have come back up 4 feet if this original was 5 feet. Okay, and then if I multiply 4 times 0.8, this would be 3.2 feet, and so on and so on. We want to know where the ball would bounce. Okay, so it's going to bounce. You don't catch it. It goes up to here the first time, comes back to the floor, comes up to here the second, goes back to the floor, comes up to here again, and then back to the floor and back up to this height on the 4th bounce. So all they're asking us to do is the function, or the expression, is 8/10 to the x, where x is the number of bounces, and they want us to know on the 4th bounce. So you just put a 4 here. So that's going to equal 8 to the fourth power over 10 to the fourth power. So I'd know that 8 times 8, wow, 8 times 8 is 64. Okay, that's 8 squared. Multiply that by 8, you get 512. Okay, and this is a 0.8, right? So 8 times 0.8 is 6.4. 6.4 times 8 is 5.12. Multiply this by 8. 8 times 2 is 16. 8 times 1 is 8, plus 1 is 9. 8 times 5 is 40. Okay, and so this is going to be 4096. Okay, so I'm not doing a decimal here. I don't know why I have the decimal. Disregard that decimal. So it's 8 times 8 is 64, times 8 is 512, times 8 is 4096, all over 10 to the fourth, which is 1 with 4 zeros, which is 0.4096, because it's 4096 tenths, hundredths, thousandths, 10 thousandths. Okay, so that is approximately, actually, let's keep it equal. That equals 40.96%, if you will, of the height that it was dropped from. So the fraction answer actually is right here. Okay? But that can be reduced. So half of 4096 is 2048 over half of 10,000 is 5,000. And half of 2048 is 1024 over half of 5,000, which is 2,500. And I can keep reducing this. Half of 1024 is 512 over half of 25 is 1250. And half of 512 is 256 over 625. Okay, keep going. Half of 256, 128 over 3. Can't do it by twos here. So I'm not certain this would reduce any further. And I don't want to take the time in this video, so I'll just use a calculator to check that. So let me get Desmos. And I want 256 divided by 625. So if I go to Desmos and put 256 divided by 625, I get that same 0.4096. Click on that, and it does not reduce any further. 256 divided by 625 is the fraction reduced. Okay, so that's where we're going to stop on this lesson. And this was on day 3, and we will finish this lesson on another day. Okay, this is the second part of session 3. Study the example showing how to evaluate an expression that involves powers with the same exponent, then solve problems 1 through 6. So it says to evaluate the expression -3 over 2 to the fourth power, all to the power of 2. So they took the original and they distributed the 2 to the numerator and the denominator. And a -3 squared is +9. And they did the power rule here. 4 times 2 is 8. And 2 to the 8th power is 256. And they get the final answer. So that is what we will be doing today, is multi-step problems. So for part A, I'm going to take -10 to the third power times 6 to the third power. Well, look at what they did up here. They distributed the 3 throughout. So that's what we're going to do. So this is going to equal -10 to the 3 times 3, which is 9, times 6 to the third power when that comes inside. Okay? So -10 to the 9th power is -1 with 9 zeros. Why they're using such large exponents to explain this, I don't know, but there it is. It's -1 billion. And then 6 cubed is 6 times 6 is 36, and 6 times 6 is 36. Carry the 3. 6 times 3 is 18, plus 3 is 21. So that is 2 times 216. So my answer to this problem is, I'm running out of room, I'll write it up here, -216, and then 10 zeros, 9 zeros. So that was -216 billion. Okay. B, I'm going to rewrite it as 3 to the 2 times 3, which is 6 over 5 cubed. 3 times, so let's do this. 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243. I can't go any further in my head, so 243 times 3 is 9, 12, 729. So this is 729 over 5 times 5 is 25, times 5 is 125. Okay? And there we have it. Number 2. Rewrite the expression as a product of 2 powers or a quotient of 2 powers. So they don't want us to evaluate this, thank goodness. They just want us to distribute the 8. So it's going to be 6 to the 8th power times 13 to the 8th power. And we're done. B, that's going to equal, distribute 9 to the 7th over 14 to the 7th. Number 3, or part C, 3 to the 10th power is going to stay 3 to the 10th power for now. 32 to the 5th will become 32 to the 5 times 2, which is 10, times 3 to the 2nd power, or 3 squared. And then that can be simplified as 3 to the 10 times 3 to the 2 is 3 to the 10 plus 2. So that's going to be 3 to the 12th times 32 to the 10th power. Okay, don't forget your rules. When multiplying, we add the exponents. When taking powers of powers, we multiply. D, 4 to the 5th times 5 is 4 to the 25 over 9 to the 7 times 4, and think of that as 4 to the 1. So 4 to the 25 divided by 4 to the 1, let's separate this. This will now become 1 over 9 to the 7th power times 4 to the 25 over 4 to the 1, right? Which would become 1 over 9 times, I forgot my 7, 1 over 9 to the 7th times 4 to the 25 minus 1 is 4 to the 24th over 1. And when I put those back together, it would be 4 to the 24th over 9 to the 7th. So this would be our answer. E, we're just distributing the 5. That's going to become 7 to the 20th power times, and I'm going to keep these separate like I did this one here. See how these 4s had the same base? Now I'm going to have 24s. So this is going to be 24, and it's 5 times 3, which is 15. And this 5 is going to distribute down here, and that's going to be 24 to the 5th. So this is going to simplify to 7 to the 20th power, that's from here, times 24 to the 15 minus 5, which is 24 to the 10th. Okay. Whew. Okay, this one, distributing the 6, we get 15 to the 9 times 6, which is 54, over 8 to the 3 times 6, which is 18. Okay, that one was easy. We're done. Okay, What is the value of this expression? So I always like to rewrite these because they're kind of small. 5 to the fourth times 2 to the fourth all over 10 to the power of 3. So I'm going to show all my work here. It's going to be 5 to the 4 times 3, right? I'm multiplying this to here, times 2 to the 4 times 3 divided by 10 to the third. Simplifying that, we get 5 to the 12th times 2 to the 12th over 10 cubed, okay? And there it is. So it says, what is the value of the expression? So I wonder if they want us to continue. Wow, those are going to be really, really big numbers. I'm just going to stop right there. If you know the process, that's fine. You can always check it with a calculator, but anyhow. Number 6. Number 4. When a ball is dropped, the height of the ball reaches after it bounces is a fraction of its original drop height, which we did in the prior lesson, or the beginning of this lesson. The expression shown for each ball given the fraction of its original drop height that the ball reaches after x bounces. What fraction of its original drop height does each ball reach after the third bounce? So this is going to be 3/4 cubed, which is 3 cubed over 4 cubed, which is 3 times 3 times 3, which is 27, over 4 times 4, which is 16, times 4 is 64. Okay, so there's the first one. The second one would be 2 to the x over 3 to the x, and we're done. If we don't know what x is, that's all we can do. And a softball is 3 to the 10. I don't need the parentheses anymore when I'm doing this. I wanted an equal sign. And it's going to be 3 to the x over 10 to the power of x. Okay, and that's it. What fraction of its original drop height does each ball reach after the third bounce? Okay. Oh, I'm sorry. I just did x's here. I'm supposed to put a 3 in. I did it on the first one. I didn't do it on the others. My fault. Let me go back and do that. So it'd be 2 over 3 to the third, which is 2 to the third divided by 3 to the third, and 2 to the third is 8, and 3 to the third is 27. So 8/27. And then this one is 3 over 10 to the third, which is 3 to the third over 10 to the third, which is 27 over 100. Okay. All right, number 5. Moses plans to make a large cube sculpture for a city park. He first makes a smaller cube to use as a model of his sculpture. The edge lengths of the models are each 25 inches. The edge lengths of the sculpture will be 3 times the model's height. So let me explain what they're doing here first. So if I drew a square or a cube, here's a cube. Okay, so if I just bring that up like so, and then draw, bear with me here, since it's inside, we can't see it. We make it dashed. Okay, so there's our cube. And what they're saying is the edge length of the models are each 25. So this is 25 inches. The height is 25 inches. And the depth is 25 inches. So it's a cube. We're going to do 3 times that model's edge length. How many times as large is the volume of the sculpture than the volume of the model? Show your work. So volume equals length times width times height. So the volume of the original cube is 25 cubed because they're all the same, right? 25 times 25 times 25, which is 25 to the third power. 25 times 25 is 625. 25 times that is, carry this, 31, 0, 10, carry the 1, 5, 12, add 5, 2, 6, 5, 1. So it's 15,625 inches cubed. That is the volume of the original. We're then going to scale this puppy up 3 times, okay, making it 3 times as big. In other words, 25 times 3 is 75. So now we're going to make it 75 inches wide by 75 inches deep by 75 inches tall. So the volume of the new one is going to be 75 cubed. How many times larger? So all we need to do, let me go back in time, and it's right here. Area of the new design divided by the area of the original. Okay, so the area of the new design, 75 cubed, divided by the area of the original, which is 25 cubed. Okay. So this is 115,625. And just to save time, I'm going to take the cube of 75. Let me go back and get my Desmos back. And I'm going to do 75 cubed. 421,875. So this is 421,875. We're going to divide that by 15,625. So now I'm going to take this and divide it by 15,625. And the answer's 27. Okay, so we got 27 times. Okay, so what we're really doing is we're taking this 3 times, and all we had to do, I wanted to show where this comes from, but all you have to do is when something is scaled up 3 times and it's a cube, okay, then it's going to be the scaled up amount, which is triple 3 times to the 3rd power. And 3 times 3 is 9 times 3 is 27. That is all we had to do to get this answer instead of all of this. Okay, so you just take this to the power of 3 because it's cubed. Number 6, evaluate the expression for when n equals 6. So this is a substitution problem. So this is going to equal 8 to the 3 to the 3 is 8 to the 3 times 3, which is 8 to the 9, over 2 to the 6 times 4 to the 6. So all I did was replace these n's with 6. Okay, and they want us to find the value of this. So 8 to the 9th is 8 times 8 times 8 times 8 times 8. I'm doing this for a reason. 9/8 all over 1, 2, 3, 4, 5, 6 2s, and 1, 2, 3, 4, 5, 6 4s. Okay, that's expanded. So here's all we have to do. 2 times 4 is 8. So if I get rid of a 2 and a 4, I get rid of an 8. 2 times 4 is 8. 8 divided by 8 is 1. 2 times 4 cancels, and we get rid of another 8. 2 times 4 is 8. Cancel it out. 2 times 4, 8. 2 times 4, 8. So my answer becomes 8 cubed, or 8 times 8 times 8, which is 64 times 8, which is 512. Okay? So really what I should have done was done the same thing here. So let's do that now. 5 to the 12th is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 fives, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 twos, all over 10 times 10 times 10. All right. So I'm going to get rid of 3 fives, and I'm going to get rid of 3 twos, and that will get rid of 3 tens, because 5 times 2 is 10. So my answer is 1, 2, 3, 4, 5, 6, 7, 8, 9. This is going to become 5 to the 9 times 2 to the 9. Okay, so that's actually a little more simplified. And then we would still have to take 5 to the 9 and 2 to the 9 and calculate that. So I'm just going to stop there. And I believe that is the end of this lesson. Let me make sure. Yes, that brings us to the end of session 3. Thanks for watching and have a great day.